Good morning, students. My name is Courtney Grimes. I am the Math 6 Advanced as well as Middle School Algebra 1 teacher at Denton Magnet School of Technology. We have quite a bit of content to cover this morning, so if you have your math packet, go ahead and take that out, as well as a pencil and paper so that you can follow along in today's lesson. And we're going to start with the two-way table. Within our standard for the two-way tables, we can identify our goals. So it states, to summarize categorical data for two categories in two-way frequency tables. We're also going to interpret relative frequencies in the context of the data, and then we're going to recognize possible associations and trends in our data. Okay, so let's get started. Two-way tables display information as it pertains to two categories. Here's an example. Within our two-way table, you should notice that there was a survey that was taken by a group of students to determine how many students take a bus to school and how many do not. That's one category. And then how many students take a bike to school and how many students do not. That's our second category. So, what does the two-way table show us? The table below shows information gathered from 30 students. And don't worry, we'll be able to get into more information as to how we were able to calculate 30 students. They were asked if they took a bus or if they took a bike to school. As you can see from the table, some students take the bus, other students ride their bikes, take the bus, or ride a bike to school. Several students do not take a bus, nor do they ride a bike to school. But again, our main focus is on the students that take a bus and the students that take a bike. Before we begin analyzing our two-way table, we need to make sure we understand what each cell represents and be able to apply the correct vocabulary to that. So entries that are within the body of the table are considered joint frequencies. So the 5, the 6, the 7, and the 12, that is where the information intersects, and that is what we call our joint frequencies. Now, the subtotals are called the marginal frequencies. For example, the total number of students that take a bike to school is 11. Can you see where we get 11 from? That is considered a marginal frequency. The total number of students that do not take a bike to school is 19. Can you see where we get the total of 19? That is our second marginal frequency. We can also collect marginal frequency totals by looking at the rows of our two-way table. Can you determine how many total students take the bus to school? If you answered 12, good job. 12 students take the bus to school, and 18 students do not take the bus to school. So as a quick review, joint frequencies is the amount of information that is collected from the intersection of our two categories. The marginal frequencies are going to be our subtotals per each category. So let's practice. From this table, how many students take the bus or ride their bikes to school? For this example, I'm going to break down the categories, and just like we used to learn our our multiplication facts through a multiplication table, we will look at the columns and the rows. Those will be considered our factors. We'll find where the two intersect, and that will be the product. We're going to use that same exact strategy for our two-way table. But first, let's identify what information we're looking for within the columns and the rows. So it asks how many students take the bus or ride their bikes. So here is the row for taking our bus, and here's the row for riding our bikes. Where does the two informations intersect? If you answered 5, you're absolutely correct. 5 students take the bus to school and ride their bike to school. Let's take a look at another example. How many students take the bus but do not ride their bicycles to school? Can you identify the two categories we're looking for? Good. We're looking for students that take the bus and students that do not take the bus. So let's find where that information intersects in our table. So students that take the bus is here. Students that do not ride their bikes is here. Where is our intersection? Our intersection is at 7. So 7 students take the bus but do not ride their bicycles to school. Okay, I would like for you to answer this question on your own. How many students ride their bikes to school but do not take the bus? So we have the students that ride their bikes, and we have the students that do not take the bus. If your answer was 6, good job. So let's practice constructing a two-way table so that we can interpret further information. In this example, Henry surveyed students from several classes to find out if they did chores and received an allowance. 65 students did chores, and of those 65 students, 49 received an allowance. There are 26 students that did not do chores and did not receive an allowance. 10 students that did not do chores but received an allowance. Very quickly, using your paper and pencil, it does not have to be perfect, but I would like for you to set up this table and label your categories. I'm going to give you about 10 seconds. Okay, so now let's work together filling out our two-way tables. Starting with the first piece of information. Within our information, they tell us that 65 students did chores. So let's look at our two-way table and notice that our chores is in a row. We do not know so far how many students received an allowance, nor do we know how many did not receive an allowance. However, we have a total. Can you remember what we called that subtotal in a two-way frequency table? You're right, it's a marginal frequency. So 65 students did chores, so we're going to find the intersection of the chores and the total, and we're going to write 65 there. Very good. Now, of those 65 students, 49 students received an allowance. Where would we write the 49? So we're still talking about the number of students that did chores, but this time we're looking at the number of students that received an allowance. So we need to find an intersection in our table. Can you remember what we call that intersection in our table? It is a joint frequency. Good. So we have the students that did chores and the students who received an allowance. If you wrote the number 49 in that intersection, good job. Okay, let's continue. There were 26 students that did not do chores and did not receive an allowance. So let's look at this. Will it be joint or will it be marginal frequency? Within the information, we have students that did not do chores and we have students that did not receive an allowance. So that's an intersection of our categories. Therefore, we're talking about a joint frequency. Can you see where we'll place the number 26 in our two-way table? Good. 26 will be in the cell that represents the intersection of no chores and no allowance. And finally, 10 students that did not do chores but received an allowance. If you already said that that's a joint frequency, you're absolutely correct. Where would we place the number 10 in our table? Very good, students. We'll place the number 10 where the intersection of our graph meets with no chores, receiving an allowance. So that's all the information that they gave us. So now we need to be able to analyze what we have to fill in the rest of our table. Using the information provided, can you determine the totals for the remaining cells? I'm going to get us started, and then I'm going to challenge you to complete the rest of the table. You may start wherever it makes the most sense. It's like a puzzle. For me, I noticed that for the students that did chores, 49 received an allowance, yet there were 65 students total that do complete chores. So if 65 students complete chores and only 49 receive an allowance, the remaining students do not receive an allowance. So I can find the difference between the number of students that complete the chores and the number of students that receive an allowance. That difference will go in the cell that represents the students who do chores without an allowance. Can you see another way we can fill out our table? Okay, some of you guys are saying, well, can we figure out the subtotal for allowance? Absolutely. We can take the sum of 49 students that receive an allowance doing chores and the sum of students that do not do chores but receive an allowance, which is 10. And that sum will give us that intersection. Okay, so just some basic simple math will allow us to fill out the rest of our two-way table. So for the number of students that complete chores and do not receive an allowance, you should have 16. For the number of students that do not complete chores, total will be the allowance plus the no allowance, which is 36 students. And just like we mentioned previously, the subtotal for the students that receive an allowance is 59, and I got 59 from 49 plus 10. And the subtotal of the number of students that do not receive an allowance is 42. Can you tell how many students were surveyed total? Good, you just take the sum of the subtotals. So I can take the sum of the 65 and the 36, and it'll give me 101. Or you can take the total of the subtotals for allowance and no allowance, which is 59 and 42, and you will get 101 as well. So 101 students were surveyed. Here's the final table. Now that we have our table completed, let's interpret. Let's answer some questions based on our table. You try. How many students took the survey? Good, 101 students took the survey. How many students do chores but do not receive an allowance? So we have the number of students that do chores but do not receive an allowance. That would be 16 students. Awesome job. How many students do not do chores but still receive an allowance? So here we have no chores, receiving an allowance. At that intersection will be 10 students. Okay, now that we know how to fill out a two-way table and how to read a two-way table, we can now calculate relative frequencies. Using two-way tables, we can calculate relative frequencies. Relative frequencies are ratios that compares the value of a certain category to the subtotal in that category. As you have previously learned, the frequency is the quantity of just how many of a certain event occurs. Now, here's the important part. Relative frequency is how many compared to the subtotal. So that will be our formula. How many compared to the subtotal? The relative frequency is written as a fraction, which can then be converted to a decimal, which can then be converted to a percent. So let's look at a brief example, then we're going to apply this strategy to our two-way table. Here's another example. There are 12 girls in a class of 20 students. The frequency of number of girls in a class is 12. The relative frequency of the number of girls in class is 12 to 20. Remember, relative frequency is the amount to how many total. So we have a 12 to 20 ratio, the number of girls to the total number of students, which can be converted to the decimal 0.60, and we know that 0.60 as a percent is 60%. So we can state that 60% of the students in this class are girls. So let's use this strategy to calculate relative frequency. You can calculate relative frequency either by row. You can also calculate relative frequency by the column. For this cell, the relative frequency of students taking a bicycle to school or the bus to school is divided by the total number of students that take the bus to school. So let's take a look at what that looks like in our two-way table. So we have the students taking a bike to school or the bus to school. Students taking the bike to school or bus is 5. Well, how many students total take a bus to school? We can look over at our subtotal and we'll get 12. 5 plus 7 is 12. So 5 out of 12 students take a bus to school or a bike out of the total number of students that take a bus to school. 5/12 can be converted to 0.42, which as a percentage is 42%. And don't worry, if that was a little hazy, I'm going to look over it again with you. This time, let's look at it as a column. For relative frequency by column, the number of students that take a bicycle to school or take a bus to school is divided by the number of students that take a bicycle to school. So let's take a look at this. We're looking at the number of students that take a bicycle to school. Here's the number of students that take a bicycle to school or take a bus to school. Here's the number of students that take a bus to school. That's 5 students. But we also want to compare that to the subtotal of the number of students that take a bike to school, which is 11. So 5 out of the 11 students take a bike to school or a bus to school. So the relative frequency is 5 to 11. We can write that as a decimal, 0.45. Or we can also say 45% of our students take a bike to school or a bus to school. What is the relative frequency of students that take a bicycle to school and also take a bus to school to all students taking a bus to school? If you can remember back to some of the terms we use for ratios when we're trying to compare data, if we're given words, we typically look for the keyword to. So I'm just going to highlight that. To what? To all the students taking a bus to school. Well, how many students are taking a bus to school? We have 5 that take a bus and a bike, 7 that take a bus but do not take a bike. 5 plus 7 is 12. So our subtotal will be 12. And I'm going to write that off to the side. Now let's look at the actual event that we're looking for. It states, what is the relative frequency of students that take a bike to school and also take a bus to school? So we need to look for that intersection of taking a bike and a bus, and we see that that is 5. So students, that is where the 5/12 come from. We can convert the 5/12 to a decimal, which is 0.42, and conclude that 42% of the students that were surveyed take a bike or a bus to school compared to all the students that take a bus to school. Now, why do we need to calculate relative frequencies? We can use relative frequencies to determine if there is an association, can you see a trend, between the two categories. For example, does there seem to be a relationship between whether or not a student receives an allowance compared to whether or not a student does chores? Well, students who do chores and receive an allowance, that's 75%. But students who does not do chores and does not have an allowance is 72%. Can you see a trend there? Also, the number of students or percentage of students that does not do chores but receive an allowance is 28%. That's a very low number. Can you tell why? And the number of students that do chores and do not receive an allowance is 25%. Very quickly, we're going to review some of the important vocabulary terms from our two-way tables. A two-way table is a table that displays information as it pertains to two different categories. A frequency is the quantity of just how many of a certain event occurs. Relative frequency are ratios that compares the value of a certain category to the subtotal in that category. And unfortunately, we're out of time, but next week you guys will start with scatter plots. We'll look at what a scatter plot is, determine some associations, correlations, then we'll look at a line of best fit and the line of regression. Until then, you guys have an amazing weekend. Be safe, and we'll see you next week. Bye.